A very good morning. I am Dr. HimaBindhu from the Department of Mechanical Engineering, Institute of Aeronautical Engineering, and my today's topic is differential transformation manipulators and types of motion. So today, in today's class, we'll be studying about the two different topics, that is, what do we mean by differential transformation manipulators? And what are the types of differential transformation manipulators? How they work? And what are its applications? Right? And the second topic is the types of motions. What are the various types of the motions which a robot will be using, and where are they being used? And what are their applications we'll be studying? So, moving on to the first topic, the types of motions. What do you mean by motion? Generally, what is a motion? Motion is nothing but the movement of any particular object. The movement of any, for example, if we take a robot, the movement of any particular robot which takes place in a forward or an inverse kinematics dealing with the dynamic or static stability is known as motion, right? So any robot manipulator has four types of motions. Any particular robot manipulator will undergo four types of motions to travel from one end to the other end, or to do its work, its any possible work. It requires some motion. So that motion of the robot manipulator is being classified into four types. First one is slow motion, second, joint interpolation motion, the straight line interpolation motion, and the circular interpolation motion. So these are the four types of the motions based on which the robot's manipulator movement will be done from one point to the other point in order to do its work within its surrounded area, or we call it as a workplace. Within its workplace, any robots to move from one point to the other point, the motion which acts on that robot joints or the motion which acts on the robot links is called as the types of motion. Right? So let us see the first type of the motion, slow motion. What do you mean by the word slow motion? As we all know, by the word itself, slow motion determines that the movement of the robot which has been taking place at some certain constraint of time. Right? The movement of the robot manipulator which will be taking place at some constraint of the time, moving from one point to the other with respect to its axis manipulator, with a slow movement to be done in order to reach back to its original position or to perform a sweep motion characterization. The slow motion is being done. Right? It is one of the simplest type of the motion. As we all know, slow motion generally taking place. For example, this is a robot with some link been attached, right? Right, this is a robo with some link pin attached. This is the joint 1, joint 2, joint 3, and the end effector. Now, the robo has to move from one position, one point to the other point about its axis manipulator. Right. So, in order to reach its final destination from the initial position, the type of the motion which is being taking place is a slow motion. That is, it is defaulted to some speed limit. right? It is defaulted to some speed limit, that is, it is limited to some constraint of the speed. That is, the movement of the robot from one point to the other point will be done in a slow categorization, right? In a slow categorization, so that at the end of the task being done, the robot will move back to its original position quickly, and it also may perform a sweep motion, that is the movement from one end, one position to the second position. The movement, whatever has been taking place, is in a slow time and reaches back to its original position in the same constant of the time, which performs a which where the robots will reposition quickly or perform a sweep motion. So generally, this particular type of the robot is characterized by multiple joints, allowing the robot to reach its target position efficiency. As I've told you, it has multiple joints. Like this is joint 1, this is joint 2, this is joint 3. So when the robot has to move from one position to the other position, it will be taking place at some constant of the time at a slower duration, right? Where it requires multiple joints, like to move from one coordinate from one position to the other position. The coordinate movement of the robot's manipulator requires multiple joints, which allow the robot to reach its target position more efficiently, right? That is, a slow motion robot is a simplest type of the motion which acts on the robot's manipulator, right? It is a simple type of the motion which acts on the robot's manipulator. The robot is commanded to travel. As I've told you, the robot will be moved from one point to the other point, where each axis of the manipulator travel at a default speed. Default speed means it is nothing but the slow speed, right? Where each axis of the manipulator will be traveling at a slower speed from the initial position to the final destination. So this type of the motion is often used when the robot needs to reach its original position quickly, or to perform a sweep motion act, right? And the slow motion is characterized by the coordinate movement which has multiple joints, allowing the robot to reach its target position more efficiently, right? The slow motion is one of the simplest type of the motion which is acting of the robot manipulator, where it requires multiple joints to reach its target position efficiently, and the movement of the motion from the movement of the robot from one point to the other point will be taking place about the axis of the manipulator, where it travels at a slower speed from the initial position to reach its final destination, right? This is the slow motion. This is the one type of the motion which will be taking place in the robot manipulator, and this is one of the simplest type of the motion. Next, moving on to the joint interpolation motion. What do we mean by the joint interpolation motion? What is actually meant by that? By the word itself, we can tell that this particular type of the motion analysis will be taking place where with the help of each joint to reach its commanded speed, right? That is, generally the joint interpolation motion involves the robot joints moving independently. Here, the robot joints, the robot joints, whatever we are taking, The robot joints, whatever we are taking, will be moving in its independent position, where one of the joint is not dependent on the other, right? In order to move from its initial position to the final destination position, the movement of the joints will be done independently without depending upon any other type of the joint. So the joint interpolation motion involves the robot joints moving independently to reach its desired position, or we call it as a trajectory. Right? So this particular type of the robot requires the control to calculate its time. Right? It requires the control to calculate its time, so that when we are using this type of the motion to the other type of the robot, the calculation will be done more easily by taking the maximum time of the particular robot's movement. By selecting the maximum time amongst the values being used, we can calculate the calculations more easily when it is being applied to some other type of the robot. That is, the joint interpolation motion requires the control of the robot to calculate its time, which helps in taking each joint to reach its destination to the commanded speed. That is, the calculation of the robot will be taking place. That is, here we have one joint, this is the second joint, third, fourth, and the end effector, for example. Right here, from one joint to the other joint, the movement of the motion of the robot manipulator will be done independently. So this time calculation will be considered. From one joint to the other joint, or from one joint to the other joint, the time calculation to it should be done. That is, the maximum time whatever is being acquired will be taken and can be used for the other axis, right? For the other axis we can use the same maximum time. That is, for joint 1 to 2, what is the time constraint? For joint 2 to 3, what is the time constraint? So accordingly, by taking the maximum time, we can calculate the time for the other axes. This is one of the advantage of the joint interpolation motion. Now, the joint interpolation motion, when it is compared to the slow motion, has lower velocity, and the maintenance problems are also much lesser for the robot. Right? When we are using a joint interpolation motion, due to the lower velocity compared to that of the slow motion manipulator, whatever we are using, gives the joint interpolation motion gives lesser maintenance problem than that of the slow motion robot. Right? This is an added advantage to the joint interpolation motion technique. Right? Next, in the joint interpolation motion, each of the joint of the robot will be moving on its own path. As I've told you, it is independent. Right? Each joint is independent and it moves independently according to the movement of the robot. So each joint of the robot has its own path, and the motion is coordinated to achieve the overall desired movement of the robot's end effector. That is, when it is moving from one point to the other point, the path which it is traveling from point 1 to point 2, the path which it is traveling has its own path, because it is independent, because the motion is independent. Because the motion is independent and the rotation or the translation movement of the joint is independent, it travels along its own path, in order to reach from its initial position to the final position of the robot end effector. Right? Generally, this type of the motion is being used for picking and placing operations, or we can use it in precise positioning, or we can or precise manipulation. Right? So these are few of the common applications where the joint interpolation motion will be used. One is picking and placing the objects, right? The joint interpolation motion is used for picking and placing the object from one place to the other, or it also can take the tasks such as precise positioning or precise manipulation, where these can be considered few of the common applications of the joint interpolation motion. Clear? Next, moving on to the circular interpolation motion. Circular means what? By the term itself, we can tell the movement of the robo joint will be done in a circular direction, right? The movement of the robo joint will be done in a circular direction, right? That is, the circular interpolation motion requires the robot control to define the point of a circle in the workplace based on a minimum of three specified positions. That is, the movement of the robot's joint will be done in a circular constraint at a short straight line segment. That is, when it needs to move from one point to the other point, right? From one point to the other point, the robot's manipulator will be moving in a circular direction. That is, it is being done in this circular direction, right? That is, it requires some n number of points of circle in the within the workplace to minimize the time constraint, right? That is, the movements that are made by the robot actually consists of a short straight line segment, right? Not only that, the circular interpolation has more available using a programming language rather than a manual or tech pendant techniques. That is, generally the circular interpolation will be done using a programming language rather than a technical language, right, or a manual language. So for any particular robo where it needs to do some circular movement, where the robot manipulator has to undergo some circular movement, so for that particular type of the robo, initially we will be giving the programming language. According to that particular programming language, the robot will be acting, right? So here there we need to give the points of the circular point. That is, for example, it needs to move, the robot needs to move from one position to the other position in circular direction. So all these particular points, whatever are being given to cover that particular circular segment, has to be given in a step by step manner, as that of the program to which will be inserted in the programming language. Now, when all these particular points are being given exactly using the programming language, accordingly the robot will be acting and finishes its task of the end effector. That is, the circular interpolation motion in robot involves moving of a robot arm or the end effector along a circular path, as I've told you. Right, along the circular direction, the end effector movement will be done, where all these programming will be given to the robot controller in the form of programming language, and accordingly it will involve its end effector in a circular direction, right? Circular path which will be defined in a linear and a rotational movement, right? The linear movement, where is the linear movement? And when the segment has to move from one point to the other, that is from one in a line segment process, and later it will be acting in a circular direction. That is, the end effector will be acting in a circular direction by the programming language which will be given to the controller, right? So generally this particular type of the motion is being used in milling sections, or in cutting any particular tool, or any in any particular cutting section manufacturing unit, or it can also be used in tracing the circular patterns, right? Generally in these particular areas we will be using the circular interpolation motion, That is the best application for the circular interpolation motion is milling, cutting, or tracing the circular patterns in order to follow a curved trajectory or to perform the task which is in a circular direction. Right? So this is known as the circular interpolation motion. Moving on to the straight line interpolation motion. What do we mean by the straight line interpolation motion? Yes, by the term straight line, what do we mean? Right? It will be the that is here the movement of the robot's manipulator will be done, that is, or the end effectors will be traveling along the straight path, or which determines in a rectangular coordinates, right? That is the movement of the robot manipulator, the movement of the end effectors will be traveling in a straight direction, which determines the rectangular coordinate. So this particular type of the straight line interpolation motion is mostly used for controlling to execute or expert for rectangular coordinate robots. Generally, for rectangular coordinate robots, this particular type of the straight line interpolation motion will be used. And one of the best application for this particular straight line interpolation motion is arc welding, inserting pins into the holes or laying the material along a straight path. That is, arc welding is also being done in a straight motion, right? The welding will be done in a straight motion. So the robot's movement will be done in a straight interpolation motion, right? That is the application. The wherever we have this wherever the robot's manipulator will be traveling in a straight path or in any particular rectangular coordinate system of the end effector, those particular industries are being considered as the application of the straight line interpolation. So in that such applications we have arc welding, inserting a pin, that is in this particular direction we have some hole, and inserting a pin into this particular hole is also one of the straight line interpolation application, or laying the material along the straight path, laying material on material or laying material on material is also one of the application of the straight line interpolation motion, right? Now this particular type of the motion typically achieved by coordinating the movements of the multiple joints. Right? So here we'll be having multiple joints in order to travel in order for the end effector to travel from one point to the other point. It requires a number of movement. Multiple joints we'll be having, right? For the robot to move in a straight direction from one end to the other end, it requires multiple movement of the joints. So that will be taking place. We are using the straight line interpolation motion. And not only that, the often used application where the robot needs to travel a straight path or follow trajectory with a minimum deviation. It has a minimum deviation, right? To travel from one point to the other point, the specified path will be having a minimal deviation. So this is about the straight interpolation motion, how the robot's manipulator will be traveling from one end to the other end. So see here, this is the figure of the robot where we have different joints. So these are called as the joints, and these are the links which have been attached to the joint, and this is the fixed base, and this is the end effector. Now this big figure, whatever we are seeing, is a figure which has 2 degrees of freedom, right? It is the figure which is having 2 degrees of freedom. Now in this, what is happening in this particular figure? What will happen for for a slow motion, and for the slow motion of the robot manipulator to be done, this movement of the robot joints according to the links will be done in a very slow manner. Whereas in the circular interpolation, what is happening? this will be in a circular direction, right? The movement of the joints will be done in a circular direction, according to which this end effector movement also will be in a circular direction, right? Whereas when we come for a straight line motion, in straight line interpolation, what is happening? The movement of the joint will be done in a straight direction, right? The movement of the joints will be done in a straight direction, where the robot's end effector is also moving in a straight direction. Whether it is vertical or horizontal, it will be moving in a straight direction, right? So in the joint interpolation, what is happening? The joints are independent of itself. They are not dependent on any other point, whereas they are independent of itself. So when we compare all these particular four joints accordingly, what do we mean by slow motion? It involves the movement of all the joints, right? In the slow motion, all the joints are being involved so that the end effector movement will be done, right? Slow motion involves the movement of all the joints in order to obtain the constraint final task to be done. Whereas in joint interpolation, as we have discussed, the joint is has an independent movement to achieve its desired trajectory, whereas in the straight line motion involves the straight path, right? The end effector will be moving in a straight path, as I've told you, in this particular direction, right? Whereas in the circular interpolation motion, the movement of the robot will be done in a circular direction, which gives a very smooth, continuous motion along the curved paths, right? In the circular interpolation, the movement of the robot's end effector will be done in the circular direction, which gives a very smooth and continuous motion along its curved path, right? So here, by accurately controlling the robot's movement, the position manipulator allows the robot to perform in a high accuracy and efficiency, right? In the circular interpolation, which enables the position and manipulator of the robot, gives a high accuracy and efficiency. Okay, so this is about these are the four types of emotions which are involved in the robot's manipulator movement. So depending upon the type of the application, depending upon the movement of the joint, the this particular type of the motion comes into action for any robot. Clear? Next, moving on to the next topic, that is differential transformation of manipulator. What do we mean by differential transformation of manipulator? What is exactly differential transformation of manipulator? So again here, the differential transformation of manipulator is being divided into two types. First, let us see a parallel manipulator and series manipulator, right? The differential transformation of manipulator is also divided into two types. One is parallel manipulator and series manipulator, right? So when we come across the parallel manipulator, what do we mean by parallel manipulator? Where the action of the links will be taking place in a parallel direction, right? That is, a parallel manipulator is one of the mechanism where the links are connected to the ground, right? In parallel manipulator, the link of the robot is being connected to the ground and the moving platform at the same time. So this particular type of the manipulator contains high rigidity, load capacity, precision, structural stiffness, velocity and acceleration at the end effector, where the end effector linked to the mobile plate in several points. That is, in a parallel manipulator system, the base joint will be rigid, which has a load capacity, precision and structural, where the end effector linked to the mobile plate in several different points. So this particular parallel manipulator again is being divided into two categories. One is the spattle and planar manipulator. Right? Again, this particular parallel manipulator is being classified into two fundamental categories. One is the spattle parallel robot manipulator, and the other is the planar parallel robot manipulator. So, what do we mean by this particular planar parallel manipulator, and what do we mean by the spattle parallel? In planar manipulator, as you can see in the figure, the joints will be moving in x and y direction, right? That is the translation motion will be around x and y direction, whereas the rotational motion will be taking place around the z axis, right? Here in x and y direction we will be having a translation motion, whereas in the z axis we will be having a rotational motion. For any particular link, for any particular joint of the robot, the movement of the robot's joint will be in the x and y direction, it is a translation, whereas along the y-axis it is a rotational direction which will be taking place. So this is the planar parallel manipulator which will be acting. Whereas in the spattle manipulator, what is happening? Here we have, this is the fixed base and this is the moving platform, right? So here in the fixed base is being connected with the help of the two manipulators to a moving platform, where it gives both translation as well as rotational motion in three-dimensional space, right? In the three-dimensional space, the robot initially will be having a fixed base. This is the fixed base which is being attached with the help of the robot manipulator, the moving platform, where this particular type of the robot manipulator will be having both translation as well as rotational movement which will be taking place in the three-dimensional space. Right? So this is about the parallel manipulator mechanism which will be acting on the robot, where we have two types, that is parallel manipulator and a series manipulator. The parallel manipulator again is being categorized as two types. One is the planar manipulator and the other is the spattle manipulator. In the planar manipulator, what is happening? There will be a transverse movement of the robot's joint in x and y direction, and the rotational movement will be done for the z axis. You can see here also the rotational axis is being done for the z axis, whereas in the serial parallel robo manipulator we will be having a fixed base which is being connected to the moving platform with the help of the robot manipulator, where the robot manipulator's movement will be done in the translator as well as the rotational motion which acts for the three-dimensional space. Right. So next, moving on to the serial manipulator. Serial manipulator means what? It is nothing but which is connected in series. All the particular joints or links which have been connected in a series, like a chain. As we can see, this is one of the joint, this is one joint, this is one joint, and the end effector. It is connected in a series. See here, it is connected in a series. Right. In a serial manipulator, what is happening? These links are serially connected like a chain, which gives the desired motion to the end effector. That is, the movement of the motion of the end effector will be done drastically with the help of the serial connection like a chain. Right? In serial manipulator, we have a constant base. Right? This is the base which is fixed, whereas the movement of the end effector will be done with respect to the joints and the links. Right? The movement of the end effector will be done with respect to the joints and the links. That is, the serial manipulator consists of a fixed base and a series of links connected to the joint and ended to at a free end carrying the tool. As I've told you, the movement of the end effector will be done with the help of the free movement of the joints and the link which have been connected in the form of a chain. Right. So this particular type of the robo is not a closed type. That is, in the parallel manipulator, it is one of the closed type. There are no closed loops being constrained in this. By actuating the joints, one can position and orient the end effectors in the planar three-dimensional space. Right? In this particular type of the serial manipulator, the end effector orientation will be done in a three-dimensional space with respect to the end effector. Mostly, this particular type of the robots are being used in the industrial purpose. Right, the serial manipulator type of the robots are generally common in the industrial robots, and they are designed as a series of links connected by the with the help of the motor. Right. So here, what we are doing here, the movement of the robot's end effector will be done in the x direction, y direction, as well as the z direction. The movement of the end effector will be done in the x direction, y direction, and the z direction, where this jaw gripper is being placed in a parallel constraint, and this is the manipulator head, right? And this is the manipulator head which we have. And generally, what are the applications of this particular type? Picking and placing the objects, assembly of the objects, and generally all the works which can be done in the industrial robot, we will be using a serial manipulator type of the system. Right. Hope you have understood about the differential transformation of manipulator. That is, we have two types of manipulator, parallel as well as series. The parallel is being having two types, that is parallel and planar. According to the type of the joints and links, it will be acting. Whereas in the serial manipulator system, all the joints and links are being attached in the form of a chain, and generally they are used in industrial robots. And some of the few applications of this serial manipulator is picking and placing of the robot objects, or assembly disassembly of the objects, and etc. Whatever application will be used in the industrial robots. Right. Hope you have understood about the four types of the motions, and you have understood about the differential transformation of the manipulators. Right. Thank you. Signing off for today, Dr. G. Hima.
Like, share, and subscribe. Hit the bell icon for more updates.